Alright, so the problem is you buy a Mountain Dew from a vending machine. It's warm, so you want it to be cold. You stick it in the freezer because you want it to be cold now. You forget that you put it in the freezer. When you finally remember, the Mountain Dew is frozen solid and it's negative 25 degrees Celsius. So we're going to transfer this to an LOL chart and to a heating and cooling curve. Well, okay. Well, it starts at room temperature and it freezes and cools down. So I'm going to say it starts up here in the liquid state and it's going to cool down. At that point it'll start to freeze. It'll completely freeze and it'll drop to negative 25. So I'll say somewhere around here because this is negative 25 Celsius. This is the freezing point. That's 0. And as you can tell, down here is where the changes from liquid to gas. But this is it starts as a liquid, freezes solid, and becomes a gas down there, or a solid down there. So this is my heating and cooling curve, and I'm going to transfer that here. So my system is obviously a can of Mountain Dew. Well, there's a chemical change. First of all, I've gone from liquid Mountain Dew to solid Mountain Dew. So my chemical change, I think I've lost chemical energy because frozen Mountain Dew doesn't have as much energy as liquid Mountain Dew. So I'm going to say I'm going to go from 3 bars of chemical energy down to 1 bar of chemical energy for my Mountain Dew here. Now, as far as the phase, well, I had liquid Mountain Dew, and I know that up here in this part of the region for liquid is 4 bars. So I'll give myself 4 bars of liquid phase energy, and it goes down to the solid region, and I know that solid has just 1 bar of phase energy. So I got that. And then I'll look at the thermal. Well, it's I don't know, it's pretty warm up here. It's above freezing. I don't know, I'll give it, since I'm saying this is 0 and this is room temperature, I'll say I start with somewhere around room temperature, and it goes down to frozen negative 25. So I'll give it 1 bar because I've lost thermal temperature energy. So if I add it all up here, I've got well, I have 3 bars of energy initially, and after it cools down and freezes, I still have 3 bars of energy. So I've had no change overall, and nothing in or out here. So for my cold Mountain Dew, or a warm Mountain Dew, it started as a warm liquid and it's cooled down to a cold solid. So that's my answer.